All right, guys. Please make sure you turn in your homework from the weekend today. Guys, stop talking. We're going to start on 3.6 derivatives of inverse functions. So the next two theorems discuss the derivative of an inverse function. The reasonableness of theorem 3.16 follows from the reflective property of the inverse or of inverse functions. So theorem 316, continuity and differentiability of inverse functions, says let f be a function whose domain is an interval I. If f has an inverse function, then the following statements are true. If f is continuous, on its domain, then f inverse is continuous on its domain. So if the function is continuous, then its inverse is continuous. If f is differentiable, on an interval containing c, and f prime of c does not equal 0, then the inverse is differentiable at f equals c. Theorem 317 says the derivative of an inverse function, let f be a function that is differentiable on interval I. If f has an inverse function g, then g is differentiable at any x for which f prime of g of x does not equal 0. Moreover, g prime of x is equal to 1 over f prime g of x. And remember, that's when f prime g of x is not 0. And that's why it can't be 0, so we don't divide by 0. All right, so this first function, I'm going to put it in my calculator so you can see it. It's actually graphed in your book, and I just didn't put the graph on the paper. Looks like this. So there's a graph. On page 174. And it shows this. It says, what's the value of f inverse x when x equals 3? This looks like it's really hard just because the notation, but it's not. This is f of x. We're going to look at our table when x is 3. I put something in wrong. 4 x to the third plus x minus 1. Let me see. I had to write the whole function wrong. That's what I think about it, y'all. Thank y'all. All right, let's look. I want to make sure I didn't even write the whole function wrong. Oh no, I'm just looking at the wrong thing. All right, so what is the value of f prime or f inverse x when x equals 3? So if we look at the graph, what they'll show us, and here's our graph. It looks like this. If we're looking for the inverse, I'll put a little blank here. What we're looking for in our f of x is where y is 3. Remember your inverse, you have x and y switched. So then when I look at my chart, I'm actually looking for the 3 and the y value. So look for y equals 3. And then what does x equal? So your f inverse of 3 is 2. Now, here's why this makes a difference, why I should have put the function on there. You guys see right here, it's 2, 3. So your inverse would be 3, 2. So it's always going to be switched. Does everybody understand that? Oh, yeah. Inverses are always like that. When you find the inverse of a function, you switch x and y. Period. Okay, if you're actually solving a graph, then you're just switching x and y and solving for y. Right. So it says, what is the value of f inverse prime of x when x equals 3? This is from that theorem 3.17. So it says g prime of x equals 1 over f prime of f inverse 3. We're going to talk about this for just a second. So where did this come from? It says g prime of x equals 1 over f prime g of x. And remember that g of x is going to be the inverse of f of x. So f has an inverse function g of x. So on this one, where you're looking at your, I'm trying to find a place to write it that you guys are not going to look at. All we did was g of x is the same thing as f inverse -1. Write a better sequence there. So they just replaced it. Does everybody see that? Right. So then what was f inverse of 3? 2. So we're doing 1 over f prime of 2. What does that prime stand for? We've been doing it this whole section. Derivative, right? So we need to take the derivative of f. So f of x, and you don't need any of this room down here. Everything is going to fit up there. F of x was 1/4 x to the 3rd plus x minus 1. So what is f prime of x? Do a normal derivative. Don't make this hard. 3/4 x to the 2nd plus 1. What does this say to do? Plug 2 in. So 1 over 3/4 2 squared plus 1. You guys can put that into your alpha y equals 1 over 3/4 2 squared plus 1. And we get 1/4. So let me go over it one more time. Our formula from 317 says that g prime of x, the derivative of g, which is the derivative of the inverse of x, does that make sense? Is 1 over f prime of the inverse of x, f of x. So that's where that's coming from. So again, g of x is the same thing as your inverse of f of x. Then we found our inverse up here just by switching the coordinates. And then we're going to plug it into the actual derivative of f of x. You'll do this in your homework for sure. Okay, so that's where the rules are going to come from. In the last example, note that the point 2, 3, the slope of the graph of f is 4. Let's talk about this for a minute. When we plug in our x into our derivative, we get our slope, right? This one's talking about regular f of x. If this is the inverse, remember we flip it over. Okay, so that's why it's 4 and not 1/4. And at the point 3, 2, the slope of the graph of f inverse is 1/4. This reciprocal relationship is sometimes written as dy over dx equals 1 over dy over dx. I'm sorry, dx over dy. Now, I'm struggling today. It's a long weekend. It's a long weekend. I didn't even go to the beach. Too much drama happened at my house, so I couldn't even go. So yeah, still stay busy, but hot mess. All right. Graphs of functions have reciprocal slopes. So let f of x equal x squared for every x greater than 0. Let f inverse x equal the square root of x. Show that the slope to the graph of f and f inverse are reciprocals at each of the following points. Okay. So we're going to start with f prime of x because we want to find the slope of f of x, and then we want to find the slope of the inverse and see if they are reciprocals, just like the 4 and the 1/4. Okay, everybody got that? We're trying to show that. So f of x is x squared. So what's the derivative of f of x? 2x, right? Everybody good with that? So now we're going to do f prime of 2. And what do we get? Good. Then we'll box this in. So that's one part of the problem. You're going to do f inverse derivative of x. So the derivative of the inverse. It tells you the inverse is square root of x. Okay, so they give you that. Tell me what the derivative of square root of x is. 1/2 x to the negative 1/2 or 1 over 2 square root x. Is everybody okay with that? We've done that 40 million times. But this time, what are we going to plug in? What are we going to plug in for our x? 4. So 1 over 2 times the square root of 4. 1 over 2 times 2, which is 1/4. That's all you do. So you're going to do the same thing on the next one. We're going to plug in 3 the first time and then 9 the second time. Yes. Come on, guys. All right. So on B, we're doing the same thing. We already have our primes though, right? So that's one less thing we got to do. So we're going to do f prime of 3. Remember our derivative of f was 2x. So 2 times 3 is 6. Our f inverse prime of x was 1 over 2x. This time we're going to plug in 9. Square root of 9 is 3. And then 2 times 3 is 6. So it gives you 1 over 6. Mhm. Unless it's like 2/3 and then it'll be 3/2. It's always flipped over, always. When determining the derivative of an inverse function, you can have two options. One, you can apply theorem 3.17, which is what we've been doing, or you can use implicit differentiation. Remember, implicit is when you take the derivative of y, you put dy over dx. Okay, that's the only difference. That one we just did, this, where we did this. Got it? So all of this right here is that theorem 3.17. Got it? Okay. So it says find the derivative of the inverse tangent function, So our f of x is tan x. You're breaking my stuff when you come back. What's your derivative? There's a way that I can rewrite secant squared x. Not like that, using trig identities. So if you have your book, flip your front cover open, somebody will find it. Secant squared x can also be written. How about this? Anybody see that in there? You should. Secant squared x. It might be on the back side. It's in there. Guys. It'll be with your trig identity that says sine squared x plus cosine squared x equals 1. Somewhere right there. You guys see it? Yeah. Okay. So this is just a trig identity. The reason I made you look at it is because I want you to put eyes on it. It's just one of those identities. So they'll flip it back and forth. So then to do the inverse, we do 1 over f prime of g of x. Which we said g of x was the inverse of x. I'm going to write this underneath here. The inverse of f of x is going to be arc tan x. Those are your inverse functions. They are in your book as well. You should know these from pre-cal. If you don't, it's okay. They're in your book. You gotta learn them. Okay. You have to learn them. You're very good so far. All right. So then we're going to plug in 1 over tan times arc tan x squared plus 1 on the bottom. Your tan and arc tan cancel each other out. Remember, because they're inverses. Arc tan is 1 over tan. It's the same thing. It's the same thing. And that leaves you with, if you read the bottom, 1 over x squared plus 1. Derivatives of inverse trig functions. There's rules for these. Okay, so this was, how do they get the rule for the derivative of tan or arc tan or anything like that? And so that was more of a proof. So in section 3.4, you saw that the derivative of the transcendental function f of x equals ln x. Sorry, my spaces are not very big in these. Is the algebraic function f prime x equals 1 over x. You will now see that the derivatives of the inverse trig functions are also algebraic. The next theorem lists the derivatives of the 6 inverse trig functions. Note that the derivatives of arc cosine u, arc cotan u, and arc cosecant u are the negatives of the derivatives of arc sine u, arc cosine u, and arc tan u, respectively. Well, not respectively. Tan should go before secant. Sorry, I even wrote the wrong thing. Arc tan u and arc secant u. All right. So remember, I told you this was a formula, right? Like this was just a proof to show you how they got that. So this was the inverse tangent function, or the arctan. I'm going to go ahead and tell you that arctan u is u prime over 1 plus u squared. So we just had arctan x. So the derivative of x was 1, and then 1 plus x squared. That's where that came from. So all of that was just deriving this formula to show you why it is what it is. So the chances of you having to do that now are slim to none. You're just going to use these cheater formulas. So everybody got it? All right. So if you didn't understand where all that came from with the tan, why can I not talk today? Tan squared x plus 1, switching it the secant squared x, that's okay, because they were just showing you how they got these formulas. That's it. All right. Sine is u prime over the square root of 1 minus u squared. Arc secant is u prime over the absolute value of u times the square root of u squared minus 1. So again, u prime over the absolute value of u times the square root of u squared minus 1. And then remember, they said respectively cosine, cotan, and cosecant are just the negatives. So this one is going to be negative u prime over square root 1 minus u squared. Arctan, negative u prime over 1 plus u squared. And arc cosecant is negative u prime over the absolute value of u square root u squared minus 1. Your next quiz will have these on them. And your next quiz will have these. There is no common agreement on the definition of arc secant x or arc cosecant. Yeah, for negative values of x. For this text, the range of arc secant was defined to preserve the reciprocal identity. Arc secant x equals arc cosine of 1 over x. For example, to evaluate arc secant negative 2. So arc secant of negative 2. you can write arc secant -2 equals arc cosine of -1/2. And that gives you both 2.09. So it's just showing the reciprocity of it. One of the consequences of the definition of the inverse secant function given in this text is that its graph has a positive slope at every x value in its domain. This accounts for the absolute value in the formula for the derivative of arc secant x. All right, so again, that part's just explaining why those two have the absolute value and they don't have just a regular u down there. So again, arc, cosecant, and arc secant are the weird ones, but the rest of them are just normal. Use your function. So the first one says take the derivative of arc sine 2x. So our arc sine says u prime over the square root of 1 minus u squared. In this one, our u, or our function within the function, is 2x. So what is the derivative of 2x? 2 over the square root of 1 minus, it says u squared, so our whole u was 2x squared. And then just clean it up. 2 over the square root of 1 minus 4x squared. Again, don't make it complicated. The other example that we had was just showing you how you've got these rules. Now we're just using the rule. Okay, so one more time. Our u is whatever's inside this function. So if it were just x, if we did arc sine x, our u prime would be 1. Okay, so this one is 2x, so our u prime is 2. On the bottom, 1 minus, our u was 2x squared. And then all I did was square these. 2 squared is 4, and then x squared. Okay. Arctan, for arctan at the top, it says u prime over 1 plus u squared. And in this case, our u is 3x. So what's the derivative of 3x? Over 1 plus, our u was 3x squared. Clean it up. We're going to have 3 over 1 plus 9x squared. On this one, our u is going to be square root of x. It's the same thing. We just got to take a better derivative. We can rewrite that as x to the 1/2. So on the top, we need to do our derivative of u. What is our derivative of u? Which changes into 1 over 2 square root of x. That goes on top. On the bottom, we have the square root of 1 minus u squared. The square root of 1 minus u was the square root of x squared. We're going to clean up and fix it all at the same time. Remember, we don't divide, we flip and multiply. So we're going to take the top and multiply it by flip over the bottom. But what's the square root of x squared? Just x. Okay. Is everybody okay with that? Then on the bottom, I'm gonna write it right here. You're multiplying x by 1 minus x. We can write it as one big square root. So on the top, you're gonna have 1. On the bottom, you're gonna have 2. Distribute that square root. X times 1 is x minus x squared. Any questions on how I got that? Is everybody okay? All right, arc secant e to the 2x. Arc secant says u prime over the absolute value of u times the square root of u squared minus 1. And in this case, our u is e to the 2x. What would be our u prime? Question. What would be our u prime? What's the derivative of e to the 2x? Keep going. Not plus 2, but times 2. So remember, e to the x, e to the regular x is just e to the x. So your function stays, but by our chain rule, it says then multiply it by the derivative of the function inside. 2e to the 2x. Yep. So on the top, we're going to have 2e to the 2x. On the bottom, the absolute value, our u was e to the 2x. Square root e to the 2x squared minus 1. What happens if it's the same on the top and the bottom? So I can cancel those 2 out. Is everybody okay with that? Clean it up just a little more. 2 over, what's e to the 2x squared? Four x minus 1. That's your final. I'm sorry that your spacing is crappy on this. So this, a derivative that can be simplified, should be on the other page. And we're going to differentiate this. So what did we just do here? What do we got to do? How are we going to find this derivative? Nobody knows. We don't know how to take derivative. Friday, y'all are like, oh, we got this, Miss Jones. This is great. This is so easy. We got derivatives. Where are we using the product rule? Everybody see that? So the first one's going to be a rule that we just learned. The second one is going to be the product rule. So what was our rule for arc sine x? What was our rule? They're at the bottom too, if you don't have to flip back. Arc sine was what? Number 19. Over square root of 1 minus u squared. At this point, that whole bottom box, you should know at this point, other than the 6 that we just learned today, obviously. Okay, so make sure you know that because your next quiz may look like that. Just throwing that out there. Okay. Most of it you did today. You already got it. All right. So arc sine x, what's my derivative of x? One. On the bottom, square root of 1 minus, our function was x squared. Plus, we have to do the product rule here. This is the same thing as x times 1 minus x squared to the 1/2. Don't forget, because we have 1 minus x squared to the 1/2, that you have to do the chain rule as well. So once we take the derivative, then we got to take the derivative of the inside. You already know this. This is not, y'all are doing amazing on Friday with it, okay? So product rule says to do what? Yep, it doesn't matter which order you do it in. Some people do that second one first. The product rule, it doesn't matter. The only one that matters is quotient rule. So I usually do the derivative of the first. I'm gonna write a big fat. Sorry, the derivative of the first. The derivative of x is 1 times the second plus the first times the derivative of the second. So what's the derivative of this one? You've been doing it all day. 1/2 guys, look, what's your derivative of x to the 1/2? This is exactly the same, except for instead of x, we have what? 1 minus x squared. You do the same thing. So we have the 1/2. Instead of x, we have 1 minus x squared to the negative 1/2. Then because we had something other than x in there, now we have to take that derivative. So what's the derivative of that inside? Negative 2x. They already got it. These functions are no different. I don't know why you like blow your minds when you do that. You got this. I promise you. You did it all day on Friday and y'all are excited and happy about it. And now we come to Monday and it's like, we don't got it no more. Clean this up. This one's gonna we're gonna leave it alone for right now. How does this one fix? Just turns into what? You can do to the 1/2, or you can just go ahead and do 1 minus x squared. I don't care. It's up to you. Here's how I look at the other one. I see a 1/2 and a 2. So I know that's going to cancel out. I know that this 1 minus x squared is going to go on the bottom. And then whatever's left that I haven't marked out goes on the top. So what's x times x? On the bottom, the square root of 1 minus x squared. I need to put them together. Since they're all adding, I don't technically need those brackets, but I do need a common denominator. And what's my common denominator? And this is the only one that needs it, right? So on the bottom, my common denominator was 1 minus x squared. On the top, the 1 was fine. It was good to go. What is the square root of 1 minus x squared times the square root of 1 minus x squared? 1 minus x squared. And then the other one had the common denominator of the x squared. What do you see? We're left with 2 over. This is not what you're going to see in the back of the book. They're not going to like this. I'm fine with it. Okay. Why don't they like it? It's not necessarily that. It's the square root on the bottom. The square root on the bottom. Is everybody good? All right. With the differentiation rules introduced so far in this text, you can differentiate any elementary function. For convenience, these differentiation rules are summarized below. So these rules, this one and this one and this one, this one. Six is the one you're having trouble with. That's your little chain rule. So if you had a function in here, remember it's the 1 less power, put that function to the 1 less power, and then derive whatever that function is. Everything else, you had a quiz on to right here. So all of that you should know. The top one is just a regular derivative. The second one is product rule. I mean, not product rule, it's add and subtract. So it's just take each derivative of each term. The third one is product rule. The fourth one is quotient rule. The fifth one, what's the derivative of 2? 0. That's what that means. And then 6 starts with your chain rule. Number 7 is if you had x, what's your derivative of x? What's your derivative of z? 1. What's your derivative of r? That's what that one's saying. So we already know those. That's not something that I need to test you on. Okay. And then we have this absolute value of u. I'm not super worried about that, but you may want to look over that one. We tested on ln u, e to the u, log, ln, all of those we've already tested on, right? How you guys do on that quiz? That's what it's going to be. And then now we're going to add the 6 more. We're going to keep adding to this quiz. Does everybody understand that? So you're going to do the ones that we already did. And now I need you to start studying these 6. Got it? And we're going to continue doing this. Everybody okay? All right. I will not have that quiz tomorrow. I'm going to give you a chance to do your homework and study a little bit before I like blast you with another quiz. So expect it on Wednesday. Okay. Is everybody good? All right. So your homework. What? Oh gosh, do you get your homework first before you go to the bathroom? I'm struggling today. Everybody gotta go to the bathroom. Here's your 3-6. It's significantly shorter. Significantly shorter. I don't know if I circled 45 because it was a harder one or because I stopped there. So I'll look at them in just a second and let you know. All right, we need to make sure that we're working